Okay, well, we're gonna try this again. We had some difficulties at on the first one, so we're gonna start again. Welcome. My name is Ed Rojas, and I'm doing this second IoT broadcast. And there we go. Um, the idea for today's broadcast is to do a basic introduction into what is IoT, the basics of IoT, right? What is the basic architecture of IoT? So we're going to talk about the CPU or the MCU, sensors, actuators. We're going to go and then start talking a little bit into the IoT ecosystem, and then begin the conversation on standards for IoT. And that's where we're going to stop. Try to make this 30 minutes or so type of project. So what I want to do first right now is I want to show you um, I want to show you then the basics of IoT architecture. Just send this little message here, and basically what you guys are seeing right now on the screen, it's a kit. It's an IoT DIY kit, right? And you can see there the big board in the middle. That's basically your IoT. That's where your MCU, your microcontroller, it's located, right? And then around it, you're going to see various things. You're going to see sensors, and you're going to see what is known as actuators. Um, those are the three main components. On top of that, obviously, you have the OS that is going to be running on top of the MCU or the microprocessor. So there's four components, right? The microprocessor, sensors, actuator, and the OS. So I was doing research. YouTube it's has a lot of information, and hopefully this makes it through. There we go. You cannot see everything. I have to see how I can fix these things. Um, but anyway, I found this nice presentation by this professor from Columbia University about um, IoT, right? And it's exactly what I wanted to show. So again, IoT, you have the microcontroller, right? And as it says there, it's got basic compute functionality. This is what makes IoT, right? The size of the controller or the microcontroller will dictate and determine what you can do with the device that you are going to design, right? Um, the next component is the sensors, and according to the statement here, a sensor is an object whose purpose is to detect events or changes in its environment and then provide a corresponding output. I didn't know that there were so many sensors. There was a sensor for everything, which is, in hindsight, it makes a lot of sense. So if you want to have a microphone, like the famous Alexa, you want to have a microphone that collects information, then you need an acoustic or sound vibration type of sensor. If you want a sensor, you want to create your own thermostat, then you will get a sensor that, in this case, number 15, that's a thermal heat temperature sensor. If you want the sensor to activate when it detects movement or proximity, then you go to number 16. You get a proximity presence sensor. Again, if you want to do a drone, you get a number 7, navigation instruments, and a number 8, position, angle, displacement, distance, speed, acceleration sensor. Um, Pretty sure that you can have multiple type of sensors in one of these devices, right? And then you can make something pretty interesting. So again, the sensors collect information, and then they send this information, right? Then you go to the third component, which is the actuators. And the actuators is basically, um, it's basically what it says here. Hold on, I have my notes here. If I find it. An actuator allows us to physically affect the world in our own way. That's pretty freaking awesome. So actuator is basically, does what we want it to do. So if we create, if we use a sensor that's an audio sensor, right? Then we can have an actuator that is a speaker that will talk back to us, or repeat whatever it is that we told it, right? If you have if you're building a drone, then you use a quadcopter actuator according to this thing, which I'm assuming is going to give you the four motors that actually run the propeller thingies there, right? Um, so that's pretty cool. So those are the three main components, right? MCU, sensors, actuators, and then on top of that, you put on that the code that you want to run on the on this device, right? And then you can go nuts doing whatever it is that you want to do. So personally, I want to be getting one of those Raspberry Pis in the near future and start playing with it and see what I can come up with. Obviously, that means learning a programming language. I'm learning Python right now, so all this is going to come in together. So that's not everything, right? So we go to the next thing, which is the IoT ecosystem, and this is when things start to get kind of um, complicated, right? So the IoT ecosystem, and I apologize, everything is all the graphics are really nasty. I'm gonna have to play with this and see how I can do nice presentations in Google Hangouts. I'm pretty sure that there's an easy way to do it. So anyway, the IoT ecosystem, right? This is everything that is part of an IoT solution. So if we notice, we see the processors, and then obviously, as in everything else, we have multiple choices here, right? We can do an ARM processors, we can do Intel processor, Qualcomm, right? Operating systems, as I said, this is runs on top of that, and here you have a gazillion options, right? From embedded Linux to Android to Tiny OS, and I guess you have Android Auto and CarPlay. I'm going to go on a limb here and say that those are for the automobile, the car industry. You have platforms, as we said, the Raspberry Pi. It's what I want to be getting to play with, but BeagleBone and Arduino, I don't know what that is. Device types, you have routers, you have access points. I don't know what these Zira platforms are. It's just a lot of information. Infrastructure, you have Cisco Fog. Then for interoperability, you have all these alliances, all these groups that are trying to come up with standards for communications and so forth. And then on the right, at the bottom, you have your famous IoT protocols. And there's a gazillion of them, right? So you have HTTP, 6LoWPAN, which is basically IPv6 over a low power personal networks, Bluetooth, so forth. So even though the device itself seems to be very simple, an IoT device, it gets really complicated really quick when you try to make it part of a ecosystem, because you have so many options, you have so many standards, so many protocols, right? And so I want to show here really quick in the next one, it's how do you put all of this together? Again, this is in a perfect world, right? And we're not going to complicate things yet. We're going to go that in the next in the next podcast. But what do you want to do when you have completed an IoT? Well, again, you want that IoT device to do something, right? Um, and then it gets divided into these three type of areas, where it's the end nodes, the gateways, and the cloud. And it's very simple. If you are on an end node and you have an IoT device that is not IP based, then if you want to communicate with the cloud or anything on the internet, you by default you have to have a gateway, right? This gateway is going to be doing the connectivity between the end nodes and in this case the cloud. And usually the cloud is part of an IoT ecosystem, right? Because this is where all the data is going to be collected and analyzed, and your big data solution. That's why IoT and big data go hand in hand. So again, so if you use if you design a solution that is using Zigbee, let's say, right, or Bluetooth, well, those are you know not IP based communications. So if you want that information, capture that information, you have to have a device that is the gateway. So for example, let's take the wearable example, right? You put in um, your thing there on your wrist, and then it starts to capture all the information about calories burned, how many miles you have walked or run or bike or whatever, right? And then when you get close to your smartphone or your tablet, that information then is transferred to that device via Bluetooth, right? And it is when that device then, through the app that it has been developed, that it connects to the cloud, where you have decided done your created your username and your account in whichever cloud provider this device is working with, right? So the device collects that information from your wearable, and then it transmits it to the cloud, into your personal account. And this is where in the first um, podcast we were talking about all the questions, right? How is that connection, communication between your gateway device, let's assume it's your smartphone, and the cloud? How is that information being transferred to the cloud? Is it being transferred in the clear? Is that communication encrypted, and so forth? So those are things that we're going to get into later on when we start focusing on security for IoT. Now, if your device is using IP-based protocols, and most probably is going to be using then 6LoWPAN, which allows you, basically is a um, compressed version of IPv6. So if your device is using 6LoWPAN for communication, then you don't need a gateway. That device can connect directly to the cloud or anything on the internet, because it's going to be using IP-based communications, right? So that's simple. What this diagram is showing here on the left, on the end nodes, is showing you a sample of the available protocols that you can use within the IoT device, right, within the end nodes. And again, that's for low power networks, LPN. So you have the 60 gigahertz WiGig, Bluetooth, which everyone is familiar with. And by the way, they're using something called BLE, which is more secure, and it's looking like a lot of companies are going to be going in that direction. Obviously, you have Wi-Fi, and then you have the famous Zigbee Z-Wave, 802.15.4, and so forth. And on the right side, for the wide area networks, now you have different type of communication. Some of them you should recognize: GSM, 3G, 4G, LTE, 5G is coming soon. I think it's already been developed. WiMAX, right? And then you have something specific within 4G that's called LTE IoT, which it's a protocol designed specifically for IoT devices. So again, we'll talk about that in another podcast. And then you have LPWA. You also have something called Sigfox and LoRa and stuff like that. So you start to see how complicated this thing is getting, right? It's not just a question of designing or selecting the right microprocessor and the right sensors and the actuators. It's also thinking, what protocol am I going to use to communicate? Do I want to communicate directly to the cloud or to the internet, or do I want to go through a gateway device, right? If you want to go through a gateway device, which protocol? Bluetooth, BLE, Wi-Fi, Zigbee. If I want to go, or then, and then if I go through there, then what protocol am I going to use on the wide area network? Am I going to go 3G, 4G LTE? Am I going to do LTE, IoT, and so forth? So you have a whole bunch of options. And this is where it starts to get then a little bit complicated. So this next slide, it shows, the beginning into standards. And it's the ecosystem of IoT standards. And this is just a few. Um, there are so many standards. It's unreal, and so many alliances. At some point, I understood, or I heard, I read somewhere that there's 120 different standards for the IoT ecosystem. Right, 120 different standards. That's incredible. It's incredible. So the reason why that is because IoT is exploding right now. It's in its infancy, and a lot of companies want to get control of the ecosystem, be the leaders in the ecosystem, right? So they come up with their own standards and they go around looking for manufacturers to become part of the alliance and to say, yes, we're going to be using this protocol, right? And try to make that the de facto standard. Me personally, um, on the standard side, I want to go based on history, right? And IETF and IEEE always win the battle of standards. So I want to be focusing personally on those two standards for the internet. And then within the verticals, right, you have industrial IoT or IIoT, you have automotive, you have healthcare, uh, home, you have entertainment. There are so many verticals that you have to choose one uh, just to start with. If you start to choose multiple verticals, you won't be able to catch up, or it'll be too complicated. So personally, I'm going to be focusing on IEEE IETF as the standards, and I'm going to be focusing on industrial for IoT. And then once I select those, then I'll see what else I need to focus on, right? I mean, it could be that the connectivity part comes into play, right? If the device is not IP enabled, then all these things. It could be that in the future there's a consolidation, and it seems like that's the way that it's going into consolidation, because again, we can't have 120 different standards. This next slide it's incredible. This shows the Industry of Things landscape in 2016. And again, I'm sorry about the blurriness of these things, but let's see how I can make it better next time. But anyway, so again, you have verticals, you have personal, you have home, vehicles, enterprise, industrial, internet, right? And then within those, you have a gazillion. So under personal, you have wearables, fitness, health, entertainment, family, sports, toys, elderly. And underneath each one of those, you have the actual player. So for example, wearables, you have Huawei in here, you have LG, Pebble, Motorola. Um, Under vehicles, in automobile, you have Waze. Everyone is familiar with Waze. I didn't know that was an IoT. So anyway, it's incredible. Then on top of that, you have platforms, what they call platforms and enables, which is where you actually develop IoT solutions using a specific platform. So it could be IBM's, it could be GE, right? It's just incredible. And so the next slide, it shows the same setup, right? Um, and if you're going to notice, it gives you a number, and it shows you that it has over 360 IoT platforms. That's too many. That's just incredible. And then it shows you 100 plus protocols, as we discussed before. So protocols, again, you have Wi-Fi, you have Thread, which Google is focusing on right now. Right, that's part of the protocols for the connectivity side. There's some protocols that are very important uh, that we're going to be discussing uh, in future podcasts, and you're going to hear about these ones: co-op, MQTT, right? We already discussed, or we already spoke a little bit about 2G, 3G, 4G, LTE, 6LoWPAN. We're going to talk about all those things in different podcasts. The whole idea of this one, and again, it's a very basic, very quick introduction, a very basic introduction to IoT. So you can see the complexity, right? You can see the it's just overwhelming. So if you come in, as I did, from scratch into IoT, you are extremely overwhelmed from the get-go, right? Because you start looking at, well, how does it communicate? And it's like, oh, Bluetooth, LPE, and then Wi-Fi. And then the funny thing is that all of these things get clumped in the same communication protocol when they're not really the same, right? Some of those communication protocols are for the within each device, in a small area, and then the wide area network, you have different protocols, right? So since the focus at the end of this uh, podcast, that series of podcasts that I'm doing on IoT, is focused on IoT security, right? You start to see how extremely difficult it is then to have one security solution for everything, right? You can't. IoT is a different beast. You cannot look at IoT as if they were your regular corporate or PC infrastructure. It's not. It's completely. It's its own ecosystem. It's a completely different beast, right? And again, as I was saying in the previous podcast, when security experts come and make recommendations, right? Secure microsegment your network. What? I mean, we're not even talking about Ethernet protocols. We're just talking about communication protocols, usually wireless. Um, when they start talking about certificates, again, we looked at the MCU or the microprocessor that dictates what you can do and cannot do, right? Since a lot of the solutions that all of these manufacturers of IoT devices, what they focus on is on cost. They need to make sure that it's cheap enough so that a lot of people can buy it. And they also focus on battery life, because a lot of these devices are not going to be plugged in. They're going to be, either wearables where they're always going to be with you, so you're not going to be stopping all the time and actually recharging these things, and or they're going to be out in the field at like smart meters, which is what everyone uses, away from uh, power source or electric sources, right? Because that's the whole idea, is for these devices to be nice and cheap. So the type of battery that it uses, right? Or the battery, or the design for battery life will dictate a lot of the things, and we're going to go into that in future podcasts. But let me just really quickly make the statement here. If you want the device to communicate constantly, right? All the time, be connected and be sending information real time, you're going to need a bigger battery. Simple as that, right? And bigger battery means a bigger device, and it also means uh, higher cost, higher price, right? So it goes against what all these companies are doing. So these companies are looking for low end solutions with long battery life, and that's usually the drivers right now. Hopefully, it's going to change in the future. We'll see, right? When newer technologies come in. Um, so again, so the size of the CPU determines what you can and what you cannot do, right? So if you have a very basic CPU, you cannot put a Linux in there, right? OS, you have to go with a very small OS. If you have a small CPU, then most probably the CPU is not going to have any security built in. It's not going to, as we mentioned in the previous episode, for example, the ARM Cortex chip, and I forget exactly which version, but there's a version that has its own security part of the microchip, right? That it has its own CPU there, that it is in charge of doing encryption and so forth, right? It has a cost associated with it. So a lot of these devices are not going to have that. And again, it depends on how you're going to use it, and what the device has been designed for. And that's why I go back and I said, if you're going to get into IoT and focus on IoT security, as I am, you have to then uh, select a standard and select a vertical, because security solutions will not, one solution is not going to fit all of them, right? Security solution is going to be specific to a vertical. Simple as that. So in the next episode, I'm going to make sure that I learn how to do presentations better on Hangout, so they don't look like this. And I will start talking then about protocols. We're going to focus then on the low power network protocols like Bluetooth or BLE, Zigbee, and so forth, right? So stay tuned for the next one. Appreciate your time watching this presentation, and hit me up on Twitter at IoT Sec S number 3C IoT Sec. Hit me up there. Subscribe to this channel so you can get a notice when we're transmitting live. And again, if you want to participate, all you need to do is send me a DM, and I will send you the link so that we can have a conversation live. I would definitely appreciate that, because it'll help me get to the next level faster, and it'll be more fun. All right. Talk to you later. Bye.